out in order of atomic weight and then grouped them into rows and columns based on their chemical and physical properties. Steve had no idea what atoms were made of or why they behaved as they did. Nevertheless, he put them together in the periodic table almost the way we know it today, except for some of the elements were missing, because they were unknown at the time in 1869. His basic rule was this: the elements in any column or group of the table are similar to their column mates. For example, look at the first column on the left, underneath hydrogen. The elements in this group are called alkali metals. They're all soft metals that react really violently with water to make hydrogen gas. I bet you wonder why the periodic table is in rows and columns. Well, I can explain that as well. You see, these numbers up here represent how many shells there are in the nucleus of an atom, and then the number here represents how many electrons there are in the last shell. There is, however, some other things that need to be recognized on the periodic table of elements, specifically being the divisions. Divisions are what the columns are grouped in. So for example, there are metalloids, nonmetals, halogens, noble gases, the lanthanides, and the actinides. I'm going to give just a brief summary of the properties of the divisions of the periodic table. Okay, now let's start with alkali. They're lower densities than other metals, one loosely bound valence electron, and they are highly reactive. Earth metals, 2 electrons in their outer shell, electron affinities. Transition metals, hard, high melting points, high boiling points, high electrical conductivity, 7 valence electrons, highly reactive, especially with alkali metals and alkaline earth metals. Noble gases, fairly non-reactive, complete valence shell, boiling points. Lanthanides, silvery white metals that tarnish when exposed to air, forming their oxides. Relatively soft metals, hardness increases somewhat with a higher atomic number. High melting points and boiling points, very reactive. Actinides are all reactive. The metals tarnish readily in air. Actinides have very dense metals with distinctive structures. They react in boiling water or dilute acid to release hydrogen gas. Actinides combine directly with most nonmetals. Known as a spiral table of elements, if you start in the middle where my mouse is now, you can see that you need to read the table in a clockwise fashion starting from the middle. All of the elements have the exact same name. It just follows the different patterns with the different metals and different divisions. As you can see, I'm not going to go all the way, but you make this line go all the way around the entire periodic table, reading out all of the elements. Yeah, and then that's how it goes.